synthetic division, remainder, and factor theorems. This lesson is also going to deal with PRZs. To divide a polynomial, when the divisor is linear with leading coefficient of 1. For example, what does that look like? If the divisor is 1x to the first, and then it could be plus or minus constant, so for example, plus 7. If you're dividing by something like this, you don't have to do long division, you can do synthetic division. It's kind of like fake division. I know that you've studied this before, so we're going to refresh everything. There's a little box right here where you put the 0. And instead of 0, maybe you could say x-intercept or root. Okay, for example, if this was the divisor, what's the x-intercept from him? -7 would go in the box. Okay, and then right here, you put all the coefficients with all the x's. All the x's have to go there too. And then there's a huge bar right here. And the first step to synthetic division is to drop it down. Okay, some of you are saying, I kind of remember this, but I still don't know enough based on what you just said. So let's look at an example. Use synthetic division. Can I divide this polynomial by this divisor? So this is the divisor. Is that divisor linear with coefficient of 1? Is it just plain x plus or minus number? The answer is yes. So what number do I put in the box? What's the x-intercept? -2. Now I need to put all the coefficients of this polynomial with the x's. What does that mean? So if it starts off as 5x to the third, I need the coefficient for x squared. Perfect, it's a 3. I need the coefficient for plain x. That's a 2. The constant 1. Now what if it didn't have one of these terms? Then you would need to put a 0. Okay, so we're all set up for synthetic. You leave some space right there for some work. And the first step is to drop it down. Okay, so underneath here, the first number here is going to be a 5. After you do that, you multiply -2 times 5, and the answer is -10. And then you add these numbers together in the column to get -7. Okay, now you're going to take -2 times -7, and the answer is +14. You add the column together. The number down here is 16. -2 times 16 is -32. We add them together to get -31. Okay, a couple things I have to tell you now. Down here, I usually take this number, kind of section it off. That number right there is the remainder. That's the remainder, okay? So this did not divide evenly. So what is the answer? The answer to this polynomial divided by that one. It used to be 5x cubed, but you divide it by a single x. That means this one is 1 power less. This is x squared. So the answer is 5x squared minus 7x plus 16. Okay, now we also have a remainder. So I'm going to take the remainder, -31. Maybe you guys remember how to do this from grade school. And you put the remainder over the divisor, x plus 2. Okay, synthetic division. Let's do it again. Let's do synthetic division to divide x to the 5th polynomial by an x to the 1st. Yes, synthetic can be done. So what's the number that's going to go in the box? A +1. Now we need all the coefficients of the polynomial. 1x to the 5th. How many x to the 4ths? 0x to the 4ths. 0x to the 3rds. 0x squareds. 0x's. Constant is -1. Okay, so here's a great example of don't forget your x's. Leave some space for a line of work and put the bar. First step, drop it down. We'll drop down 1. 1 times 1 is 1. Add the column, get a 1. 1 times 1 is 1. Add the column, get a 1. 1 times 1 is 1. Add the column, get a 1. 1 times 1 is 1. 1. 1. 0. Let's just section that one off. Okay, and that is the remainder. So this one divided in evenly. There is no remainder. So what's the answer? Okay, let's go ahead and officially write the polynomial. This was x to the 5th. This answer is always going to be 1 power less. We divided out a single x. That makes x to the 4th. So the answer is 1x to the 4th plus 1x to the 3rd plus 1x squared plus 1x plus 1. Okay, synthetic division. You need to get really good at this because you're going to do it about 200 times before this chapter is over. All right, the remainder theorem. What if you want to know what the remainder is without doing all of this work? So if f of x is divided by x minus c, the remainder can be calculated with f of some number, and that's how you get the remainder. So how do you find the remainder? What number do you think you're going to plug into the function? And the answer is the x-intercept, or the 0, or the root. You're going to plug in a c. If you take the root and you plug it into the function, the answer will be the remainder. Okay, here's a couple of examples of this. Find the remainder, just the remainder. So I have a polynomial, and if I divide by that, I do all the work, I'll get the remainder. But I just want to find the remainder and not the whole polynomial. So let's calculate f of a 3. So if I do 3 cubed minus 4 times 3 squared minus 5, that will give me the remainder. Let's label our work. F of 3 equals 27. 9 times 4 is 36 minus 5. So f of 3 is negative 14. Okay, and what is negative 14? That is the remainder. That is the remainder. Okay, another way that someone might ask you to do this work is by saying, is x plus 1 a factor? Is it a factor? Well, if it's a factor, then it's going to go in evenly. Okay, factor means go in evenly. All right, well, let's see. Let's calculate f of negative 2. And what I'm hoping for is a 0. I don't want any remainder. So let's see what we get here. 2 times negative 2 has to get cubed. Make sure you use parentheses there. Minus negative 2 has to get squared. Do these cancel? No. No. Powers first, then adding. Plus 2 times negative 2 minus 3. So let's see. How would you do the work for this? First, let's do negative 2 cubed. That's negative 8 times 2, negative 16. Minus, that becomes a positive 4. Minus 4 minus 3. F of negative 2 is, wow, negative 16, negative 20, negative 24, negative 27. Okay, did it go in evenly? Is it a factor? And the answer is nope, it is not. Okay, if the remainder equals a 0, then it is a factor. If you get a remainder, if you get a number, then it's not a factor. So what are we hoping for here? We're hoping to get zeros. This one is not a factor. It didn't work. So now I'm going to say to you, well, try another one. You have to find the one that works. Okay, so you're hoping for zeros. Okay, some people like the remainder theorem. Some people say, why don't we just jump right to synthetic division? Okay, so let's use synthetic division to see if it's a factor. So we're going to go ahead and put the 0 in the box, which is a 1. Let's put all our coefficients. Don't forget about your axis. So we have a 2, negative 1, 2, negative 3. Okay, here we go. We're going to drop down 2. 2 times 1 is 2. Add those together, get 1. 1 times 1 is 1. Add them together, get a 3. 3 times 1 is 3. Ah, look at that. It went in evenly. Okay, if it is, okay, write f of x in this form. So f of x equals, this used to be x to the third. I divided out a single power of x, so this is x squared. Look what they say here. They want me to write x minus c. They want me to write the factor. They want me to write down x minus 1. And then they want me to write down the quotient. Okay? Quotient is the answer to a division problem. So we divided f of x by x minus 1, and the quotient is down here. 2x squared plus x plus 3. Okay? If it doesn't come out evenly, you don't do this. If it is, then you write it in this form. Is this true? F of x used to be 2x cubed. Is f of x that I wrote here, is it still 2x cubed? And the answer is yes. Every time I write down f of x, he better be a 2x cubed polynomial. F of x should never change into a quadratic. Okay, whatever it starts off with, it continues to be. It just might be in factored form. Okay, and here is the whole gist of this chapter. Get f of x into factored form. Let's do another one. Let's use synthetic division here to see if x plus 4 is a factor. Okay, you could do the remainder theorem like we did here, and then after you get a 0, and you say, yes, it works, I'm going to say, great, now do synthetic anyway. So some people just say, let's just start with synthetic, because if it works, I'll have my answer. Save time. In the box, let's put negative 4. The coefficients are 1. Where's the x to the 5th? So we're going to put 0, negative 16. X to the third is another ox, another 0 x cubed, 1x squared. 0 for the x's, negative 16. Okay, here we go. The first thing we're going to do is drop it down. 1. Negative 4 times 1 is negative 4. Add that column. Negative 4. Negative times negative is positive. Ooh, made a 0. Something times 0 is 0. Add the column. Something times 0 is 0. Add the column. Negative 4 times 1 is negative 4. That adds up to negative 4. A negative times a negative is positive. It worked! It worked. As soon as it works, if it is, write it in the factored form. So f of x equals, what's the factor that worked? If negative 4 works, then you say x plus 4. And now I have to write the quotient. This problem started off as x to the 6th, so this answer is x to the 5th. All right, here I go. 1x to the 5th minus 4x to the 4th. That says 0x cubed. I don't really feel like writing 0x cubed. Or 0x squared. That's plus 1x minus 4. I like to section off that number because that's the remainder, and then that kind of reminds me that that last number right there should be the constant. If you decided to multiply this out, you should get the original f of x. And this is what I was talking about before. If f of x started off as x to the 6th, f of x down here better be x to the 6th. See how those two firsts are f of x equaling x to the 6th? Some people forget to write the factor, and then f of x says that he's a 5th, but he's not. He's always going to be a 6th power every time you write him down. Okay, the last thing that we're going to do here are PRZs. These are very powerful. PRZs stands for possible, rational zeros. Okay, so there's lots and lots of numbers that might possibly work. And here's how you make a list of them. Okay, so PRZs are found. Here's a huge fraction bar. Okay, in the numerator, you put plus minus the factors of the constant. The factors of the constant. In the denominator, you put plus minus all the factors of the leading coefficient. Okay, and let's just remind everyone what those are. Okay, the constant is the last number. Okay, the leading coefficient is that first number that you see. Okay, so let's go ahead and do an example, and then I'll talk to you again about what these are. So let's make a list of the potential or the possible rational zeros. So here's a polynomial, and the PRZs are as follows. The factors of the constant, that's this one right here. So what numbers go into 10? Plus or minus 1 can divide into 10. Plus or minus 2. 3 does not go into 10. Plus or minus 5. Plus or minus 10. Okay, now in the denominator, you have to look at the leading coefficient. That's this one right here, 5. So what numbers can go into 5? Plus or minus 1. Plus or minus 5. So try to be organized. By starting at 1, you always start with 1 and go all the way up to the number. Now what you have to do is make every possible combination. For example, let's start with the 1. 1 divided by 1 is plus or minus 1. Take 2 and divide him by 1. 2 divided by 1 is plus or minus 2. Then 5 has to go over 1, and then 10 has to go over 1. Okay, thank you, 1. Now I have to divide all of those numerators by a 5. 1/5 plus or minus 1 over 5. Then 2 over 5. And then what's 5 divided by 5? 1. Well, I already have 1, so I don't have to say it again. 10 divided by 5 is 2. So I've already got that. These right here are factors that might possibly work. Okay? Now this is a 5x to the 4th. How many x-intercepts could he have at most? He could have 4x intercepts. So all of these are not going to work. Okay? But if you're going to start trying numbers, these are the ones that might work. Would 3 work? No, 3 would definitely not work. He's not even in the list of possibles. Sometimes lots of these numbers work. Sometimes none of these numbers work. Okay, but if you're going to start picking numbers to try, you might want to pick from the list of numbers to try. All right, let's do this last one here. Let's list the PRZs. Let's list them, and then we'll start testing them. Okay, so first of all, PRZs. In the numerator, you look at 6. So what goes into a 6? Plus and minus 1, plus and minus 2, 3, plus minus 6. Yes, you have to write the plus and minus every time. It's not hard. And then we'll divide by the factors of 2, which are 1 and 2. Now we have to make every possible combination. So let's divide by 1. Plus minus 1, plus minus 2, plus minus 3, plus minus 6. Now I have to divide them all by 2. 1 divided by 2 is 1/2. 2 divided by 2, I already have the 1. 3/2 I have to write down. 3/2. 6 divided by 2, I already have. Okay. Now we have to test to see which one are zeros. Which one are zeros? So let's try one of the numbers. Which one do you think might work? Do you want to try a 2? Okay, so we'll try a 2. You put the PRZ, that's the 0, that's the x-intercept, strictly into the box. And then the coefficients are 2, 11, -7, -6. All right, here I go with the testing. Step 1, drop it down. 2 times 2 is 4. 15 times 2 is 30. Subtract 3, 23. 2 times 23 is 46. I don't think that's working. Okay, so 2 did not work. Let's pick another number to try. Oh, you want to go back to 1? Sure, we could go back to 1. Some people always start with 1. They work themselves up the list. So let's start with 1. We'll try the same coefficients again. Okay, step 1, drop it down. 2 times 1 is 2, 13. 13 times 1 is 13. Minus 7 is a 6. 6. It worked. It worked. Okay. As soon as you find one that works, everybody stop. What we're going to do is we're going to write f of x in factored form. Okay, what was the factor that we found? 1 is the x-intercept. That's the 0. That's the possible 0. So that factor would be x minus 1. Then, next to it, you're going to put the quotient. This problem used to be 2x cubed. This is 2x squared. Okay, 2x squared plus 13x plus 6. Okay, as soon as you find one that works, you write f of x in factored form. F of x, when he started, was 2x cubed. Is it still 2x cubed? Absolutely. Now, I guess we should keep going and trying some more PRZs. Wait a minute. Do you guys notice this right here? Maybe we could take a shortcut. Instead of testing all of these plus and minus numbers, maybe you could just factor this by hand. If you could factor it by hand, then all of our work will be done. Factoring is definitely the easier way to go. Let's see, 6 and 1 or 2 and 3. I got to make a 13. What if I put a 6 times 1? The outers are 12x. The inners are 1x. Perfect. Plus, plus. Okay, now I have f of x in perfectly factored form all the way to the end. Okay, so what were the zeros? This factor right here says x is equal to 1. I found that one already. This factor right here says negative 1/2. Oh, negative 1/2, here it was. Here it was in the list. And this factor was negative 6. There it was. So if we tried negative 1, positive 2, negative 2, positive 3, negative 3, we wouldn't have found one until we got all the way to here. Okay? So your goal in life, okay, is to get f of x to the point where it can just be factored by hand. So as soon as you find one that works, write f of x in factored form. That's what we did. And if you can factor by hand, it actually will be very easy that way. Can you use synthetic division to divide a polynomial? Okay, you're going to get really good at that. Can you use the remainder theorem? So all that means is f of c, and then you get the number. It's not very useful. I can use the factor theorem to determine if it's going to be divided evenly. So what that means is f of your number gives you a 0. Can you write it in factored form? I sure hope so. Okay, I can make a list of PRZs. And then I can use synthetic division to test that list to find the one that works. Okay, I can't wait to do these with you tomorrow.